Hi, welcome to my video on the product of secants. CA is a secant because it's cutting the circle at 2 points. And CE is a secant because it's cutting the circle at 2 points. So we're going to prove the product of the secants, and that is we're going to prove that CB times CA equals CT times CE. So, and to do that, I have to form a pair of triangles. So we're going to join. So what we're going to do is, number one, we're going to join BE and AT, and that's a construction. You can draw a segment between any 2 points. As a result, we have triangles, so we need a pair of similar triangles. So what I'm going to do, I'm going to take the triangle BEC, BEC, and I'm doing them separate here, and I'm going to match it with triangle ATC, triangle ATC. So if I can prove that these two triangles are similar, then we get a proportion coming out of that, and the cross product will give me what we have to prove. So what we have here is that we have, notice that angle C, BE, oh, that's BEC there, that's a C. So BEC, ATC, there they are. So angle C is equal to angle C. Angle C is here and here, and that's common. It's a common angle in both triangles. So it's a common angle. Now we need another pair of angles. So what we have is that we have angle E, which is this angle here, equal to angle A. Angle E equals angle A. And these are two. BET is an inscribed angle because it has two chords with a point on the circle. And BAT is an inscribed angle because A is on the circle, and these are two chords, A, B, A, T, and these are equal because both B, A, T and B, E, T are intercepting this common arc. So they're equal. Inscribed angles which intercept an arc. I won't say common arc, intercept an arc are equal. So these two inscribed angles A and E are intercepting the arc BT, so they're equal. That means we have angle A, we have angle C, which is right here. It's a pair of angles equal. Angle C is equal to angle C. Angle A is equal to angle E, because two angles are intercepting the same arc. That means we have a pair of triangles, and I'm going to name the triangles as CBE, CBE is similar to, so C goes with C, B goes with the T, and E goes with the A. And the reason is A similarity. If two pairs of angles in one triangle are equal to two pairs of angles in another, then the triangles are similar. You only need two pairs of angles equal, not three. And as a result, we have a proportion that CB over CT is equal to CE over CA. So you can see the C goes with C, B is going with T, E is going with A. And the reason for that is the corresponding angles of similar triangles, corresponding sides, when I said angles now, corresponding sides of similar triangles are proportional. Corresponding sides are proportional. Corresponding angles are equal. And number, that's a 5 right there. And number 6 is that we cross multiply CB times CA is equal to CT times CE. And that's the property of proportions. You can cross multiply. So we had the proof done, but we had to set up the two, draw the two segments to get the triangles and get two pairs of angles equal. So that's the proof. I call the proof a product of the secants. But another way that I write that down, which is a trick that I do, is that I say outside times all equals outside times all. That's the trick that I use. Outside, see, this is a secant, so the outside the secant is CB, and all of it is CA. And this secant, the outside is CT, and all of it is CE. So I keep this, when I see secants and I want the product, the lengths, this is how I think about it. So let's do this, a couple of these questions based on this proof that we just did. And notice we have secants, two secants, drawn, cutting the circle. And we have the outside. So if I write down outside, times all equals outside times all. So let's take this one. 4 is the outside, and all of it is 4 plus 11. And this secant, the outside is 6, and all of it is 6 plus x. So we solve this. We have 15 here, and we can't simplify the inside here, so that gives us 60 equals 36 plus 6x. And I can leave the 6x there and move to 36. So 6x equals 24. Divide by 6. X is equal to 4. And let's see. Let's put 4 back in here. So, as a check, outside is 4. All of it is 15. This one outside is 6. And all of it is 6 plus 4 is 10. And 60 equals 60. So 4 is the correct answer. Again, I use outside times all. And we have another one to do. And again, what I do is this is secant TA and secant TF intersecting circle. We have parts, so outside times all equals outside times all. So let's take, don't make any difference which one we take. Let's take this one, TA. Outside is x. All of it is x plus 6. And this secant, outside is x plus 1. All of it is x plus 1 plus 3. So all of it is add these together. So we can't simplify that. What I'm doing the inside of the bracket. Now instead of writing down x plus 1 plus 3, I could have added this, and got x plus 4 right away without giving you this. Now we multiply x squared plus 6x, and we do the FOIL on this, x squared plus 4x plus x plus 4. Outside, first, outside, inside, last. And we simplify the right side. Again, the less terms we have when we transpose, the better. 4x plus x is 5x. The x squareds are on each side, so we cancel them out. So 6x minus 5x equals 4. Notice the x squared cancels out. I have no quadratic. So we put the x's on the left, numbers on the right. So x equals 4. And again, to do a check on that, let's put 4 here. And x is 4, so that's a 5. So let's check. Outside is 4. All of it, 4 plus 6 is 10. And in this one, the outside is 5. And all of it is 5 plus 3 is 8. And 40 equals 40. True, so 4 is the correct answer. And another one to do. Again, just more examples. But this time, here we found x. Now I got to find AB. So we got to find what x is and then get the length of AB by subbing the value of x in. So here we go again. Outside times all equals outside times all. So let's take this one. Let's take AC, got x here. Outside is x. All of it is x. Add on 4x plus 5. So I could have called this 5x plus 5 right away, but I just didn't. And this one, the outside is 3. And all of it is 3 plus 7. So let's simplify inside the brackets first. 1x plus 4x is 5x plus 5. 3 plus 7 is 10. Now multiply. 5x squared plus 5x. 3 times 10 is 30. And it's a quadratic, so we move everything to the right in descending order. X squared, then 5x minus 30. And we got a quadratic, but I see a 5 as a GCF, so take the 5 out. I have an x squared plus x minus 6. Quadratic, let's see if we can factor it. The product is 6. Sorry, the product is negative 6. The sum is plus 1. So the factors of 6 are 1 times 6 and 3 times 2. The sum is negative 6, so one of these numbers got to be negative, and one got to be positive. And the factors of 6 to give me a 1. 6 and 1, no matter what I do, add or subtract, I get 7, or I get a 5, or negative 7, negative 5, so 3 and 2. But to get a positive, I have to have a positive 3 minus 1. So x plus 3, x plus 3 minus 2, multiply. 3 times negative 2 is negative 6, add, plus 1 equals 0. So 5 can't be equal to 0, so x plus 3 equals 0, or x minus 2 equals 0. 5 cannot equal 0. The values of x that give you 0 must be in these brackets. So x is negative 3, x is 2. And we check 3. If we take a 3 and put it right here, it becomes negative. So that means subbing the negative 3 in makes BC negative, so we can't use that. So 2. So let's put 2. Let's just check. We got a 2 here, and we put a 2 here, so that's 8, that's a 13. So as a check, outside is 3, all of it is 10. And this one outside is 2, and all of it is 15. All of it is 2 plus 13, 15. 30 equals 30. Perfect. 2 is the answer. But we have to find the length of AC. Sorry, AB. I said AC, AB. And AB is 4x plus 5. And 4 times 2 plus 5. That's 8 plus 5. So we have a BC is 13. Well, I did 13 right away just to check to see if the 2 was okay. Because if the 2 wasn't okay, then there'd be no solution to this problem. So 2 was okay because it made the length positive, and then I knew that this was going to be 13. Okay, that brings us to the end of the video on the product of secants. Again, I use outside times all equals outside times all. Good way to remember it. And if you like my video, click on the like button. You want to be a subscriber of my channel, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you. With Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.